Welcome back to RamZland. Today I want to show you the combustion redox reaction of burning magnesium in dry ice. Check this out. All I'm using in this experiment is magnesium ribbon, a pair of needle nose pliers, a graduated cylinder, and a block of dry ice. The first step is to break up some chunks of your dry ice that you can fit in your graduated cylinder. That's a little big. Still a little too big. I think this one will fit. The second step is to generate carbon dioxide gas, and we do that through the sublimation of dry ice. So down here, the dry ice is a solid, but if I add some water, that dry ice that's about negative 90 degrees below zero, if I add water, it starts to sublimate and it changes from a solid to a gas. Sublimation here is when a solid skips the liquid state and it goes straight from a solid to a gas, and I can see that white gas coming out. That's carbon dioxide. So we know that fire requires fuel, oxygen, and heat. And fire extinguishers use carbon dioxide because it's such a dense gas that it smothers the fire, so it can't get oxygen for combustion. So if I light this match and I lower it into this graduated cylinder, that carbon dioxide should put out the match. Let's try it. And it puts it out very quickly. Let's try that again. Right away, it puts out that match. So if carbon dioxide gas will smother a flame, what do you think carbon dioxide gas would do to burning magnesium? Would it put it out, or would the magnesium keep burning? Let's find out. I have a nice magnesium ribbon. I'm going to start it on fire and lower it into the carbon dioxide. And it keeps burning. How is that possible? This is why fire extinguishers don't put out magnesium fires, because the magnesium will just keep on burning. What do you think makes that possible if there's only carbon dioxide gas inside? How does it keep burning? Look at that. Just amazing. So the product in this reaction is carbon and magnesium oxide. That white powder that you see, that's the magnesium oxide. And those black flecks along it, that's carbon. So how does magnesium keep burning in carbon dioxide? It is so reactive, it pulls the oxygen atoms right off the CO2 molecules and continues to combust. Just incredible. So what's going on in this amazing oxidation reduction reaction is you start out with the reactants, magnesium ribbon and carbon dioxide gas, and you get the products, magnesium oxide, that was the white powder that you saw on the ribbon, and elemental carbon, those were the black flecks that you saw on the ribbon. And this is because magnesium is higher on the reactivity series for metals than carbon, and so carbon is able to reduce magnesium. Well, I hope you enjoyed today's edition of RamZland, and I'll see you next time.